Hello students, welcome back to one more video. And in today's class we are going to study about Heisenberg's uncertainty principle. Okay, in last class we studied about de Broglie's equation, and that de Broglie's equation says that every material particle have a wave nature. Okay, and that material particle he has explained also by giving his equation. Now let's see that what is this Heisenberg's uncertainty principle says. Okay, now tell me that if I'll give you few example. First of all, here I am taking a moving car. Okay, here I am taking a moving car, although my drawing is not so good, but let me try. If a moving car is there, so can you calculate position and velocity? What I am saying? I am saying that can you calculate position and velocity of that particular moving car? Yes or no? I think your answer is yes. Yes, it means we can calculate position and velocity of that moving car. Yes, the position and velocity of a moving car. Now take another example in the game of cricket. Okay, when the bowler is throwing the ball, okay, to out that player, so I think that bowler is assuming or predicting what can be the velocity and what can be the position of that ball so that batsman get out. Yes or no? तो ये हमने देखा है कि वो पर्टिकुलर बॉलर जो है वो ध्यान से देखता है कि भाई मैं कहाँ पर बॉल इसकी डालूं, मतलब पोजीशन कहाँ पर आना चाहिए उस बॉल की और वेलोसिटी कितनी होनी चाहिए ताकि वो स्टंप को उड़ा दे और वो बैट्समैन जो है वो आउट हो जाए. ओके, सो ये जो हम देख रहे हैं, व्हाट इज दिस? दिस इज ऑल अबाउट पोजीशन एंड वेलोसिटी. इट मीन्स वी कैन मेजर द पोजीशन एंड वेलोसिटी of that moving balls as well, right? Okay, now let's see that now the question is that why I told you all the things together, because this is actually not applicable for the electron. So we can measure a position and velocity of a moving ball. We can. What is this Heisenberg's uncertainty principle says? Heisenberg's uncertainty principle says that it is not possible to measure position and momentum of a microscopic particle. As we took the example of moving car or throwing ball, we can measure the position and its momentum, but according to Heisenberg's principle, we cannot measure the position and the momentum of a microscopic particle with absolute accuracy or certainty. According to him, either we can measure its position or we can measure its momentum. So it means out of these two, one will be accurate but another will not be certain. This is actually the Heisenberg's uncertainty principle. Or in simple words, if you want to see that how can we explain, हम ये कह सकते हैं कि Heisenberg क्या कह रहा है कि भाई किसी भी माइक्रोस्कोपिक पार्टिकल का या तो आप पोजीशन एक्यूरेटली मेजर कर सकते हो या फिर उसका मोमेंटम एक्यूरेटली मेजर कर सकते हो. ये पॉसिबल नहीं है कि आप पोजीशन और मोमेंटम दोनों एक साथ accurately measure करो. And the Heisenbergs has explained for this as, consider that if the electron is moving in this way, here what I am saying that this electron is moving, this is the actual path of electron. Okay, actual path of electron. Okay, this path we can use this word as a trajectories also. Trajectory. So this is the actual trajectories of electron. So electron always should move from this way. Now when I have used microscope to watch this electron, so everybody knows that whenever we are using a microscope, we need to set light or incident line. So as soon as this incident light strike on this electron, incident light strike on this electron is displaces from its original position and even it will change its path. It can change its path, and this is known as, so actual path is this one, so there is a possibility that he is now moving from this side, so this can be a new path of that electron. So what he is explaining, he is saying that if you are when incident light is attacking on that electron, that position or momentum cannot be exact. ओके, वी कैनॉट मेजर इट एग्जैक्टली. तो अब इसके लिए क्या है, देखो इसके लिए दो हो सकते हैं. अब सबने क्या कहा कि आप क्या करो, ये जो लाइट जो ले रहे हो, टेक दिस लाइट इज ऑफ शॉर्टर वेवलेंथ, टेक द लाइट ऑफ शॉर्टर वेवलेंथ. अब क्या होगा, जैसे ही कोई लाइट की शॉर्टर वेवलेंथ होगी, इफ द लाइट इज हैविंग द शॉर्टर वेवलेंथ, देन इट विल हैव हाई फ्रीक्वेंसी, इट विल हैव हाई फ्रीक्वेंसी. और जब कोई हाई फ्रीक्वेंसी का, जैसे अगर ये कोई इलेक्ट्रॉन है यहाँ पर, इफ आई एम यूजिंग इन दिस वे, if now here is the electron, when the incident light is coming from this side with a very high frequency, so what will happen, as soon as it will come, it will strike on this, and when it will come and strike on this will change from its position, and जो हमें माइक्रोस्कोप में पोजीशन दिख रही है, that will not be a actual position of electron. So some of the scientists suggested that in place of shorter wavelength, you can use a wavelength of longer you can use light of longer wavelength, and longer wavelength light will have low frequency, and they can also change the position and momentum of a microscopic particle. So according to Heisenberg's uncertainty principle, for microscopic it means those which we are seeing under the microscope. So for microscopic particles, momentum as well as position cannot be measured accurately or absolutely. So he has given one mathematical expression also. What is that mathematical expression for explaining this? He has given this expression as delta x into delta p is greater or is equal to h upon 4 pi. Okay, so what is x? X is the, we will say that certainty or uncertainty, I'll use this word as a uncertainty in position. What is this? This is uncertainty in position, and delta p means what? It is uncertainty in momentum. And how can we calculate? We can calculate as m delta v. And what is this h? H is Planck's constant. H is Planck's constant, and pi, that we know very well. So this is the mathematical expression by which we can calculate the possibility, or for calculation purpose we are using this as a delta x upon delta p is equal to h upon 4 pi. Okay, so this formula we can use, and we can calculate the certainty in position as well as certainty in momentum. Okay, so student, this is actually the Heisenberg's uncertainty principle. Now if we will see that this microscopic, this is only applicable for the microscopic particles, not for day to day. So Heisenberg's uncertainty principle is not having any significance in day-to-day life. Light. In class 9th we studied that after studying Rutherford's model, we know that electrons are revolving around the nucleus inside the atom. So why electrons cannot be present inside the nucleus? Why electrons are not part of the nucleus? For the answer for this question we can explain it through the Heisenberg's uncertainty principle. Now if electron, here I am writing this. Now if electron, so see, if electron wants there in the nucleus, then electron should have speed of light. Electron should have the speed of light, and speed of light, that is 3 into 10 to the power 8 मीटर पर सेकेंड. अगर इलेक्ट्रॉन की स्पीड अगर इतनी है तो इलेक्ट्रॉन क्या कर सकता है, न्यूक्लियस के अंदर आ सकता है. नाउ इफ आई से हियर आई विल राइट दैट सर्टिनिटी इन पोजीशन. एज वी नो दैट diameter of nucleus is 10 to the power minus 15 meter. Okay, so if the diameter of nucleus is this much, so if the electron is having this diameter, so or if electron can exist, the position of electron can be between this, then it is possible for electron to be there in the nucleus. Okay, now how we are going to explain this? On the basis of Heisenberg's uncertainty principle, let's see. As we know, the formula of it, formula is what? Delta x into delta p is equal to h upon 4 pi. So here I am taking it as a delta x into, it is m delta v, h upon 4 pi. What is this m delta v? Momentum. P stands for momentum, so we have converted it into m into v. So now velocity, I will calculate whether the velocity of electron it is equal to the speed of light or not, and I will write in this way as velocity, so h upon 4 pi into delta x into delta v. Delta v we are calculating, so delta x into small m. Now let's put all the values of this value. H stands for Planck's constant, and the value of Planck's constant is 6.626 into 10 to the power minus 34 upon 4. We know 3.14 we will take, and delta x for position we are taking this value for delta x because uncertainty in position, so it would be 10 to the power minus 5. And here what is m? M stands here for mass of electron, and mass of electron we know, and that mass of electron is 9.1 into 10 to the power minus 31. Now students, see, when I will calculate this value, here I am writing, when I will calculate this value, I can get this as delta V is equal to 5.79 into 10 to the power 10 meter per second. So the actual value of speed, it should be the speed of light, but electron is having more value than the required, and this is the reason that electron cannot be a part of the nucleus, or electron cannot exist inside the nucleus, because certainty in position and certainty in its momentum is not possible. So students, I hope you understood today's topic also. Please read the topic properly, and whatever doubts you have, please ask me. And if you really like my video, you can write it down in the comment section, and if you are new to my channel, please subscribe to it and like, share with your friends. Thank you students, and have a